But it's a beautiful day for science. I have been noticing there are a lot of new activity, or there is a lot of new activity that is occurring in different places, as well as some continuations that strike my intrigue, including Stanley, Idaho, and of course Geysers, California, have been my two most focused points for a long while now. But now we also have activity in Ohio. I believe there was one recently in New York, and also one in the Carolinas. So I've been keeping an eye on these. A lot of new activity, and so far can't find exactly what the progression is, but I'm sure it'll show itself eventually. Looking at the overall 30 days, all magnitudes, is the easiest way to see the correlations. I don't really predict earthquakes, but I do follow observations. And the observations show that there is a line of progression that occurs. And following that line really tells you what is happening within the Earth to some degree. And as you can see, there is a steady way of this activity where it connects all of those events to a single type of event. So we can tell these things are majoritarily seismic. No, of course, seismic. Platonic, tectonic. So these are, of course, not volcano earthquakes, which is, of course, a relief for everybody that's concerned about the Yellowstone and other volcanoes activity. Although there is a slew of new activity I've been watching in Mount St. Helens, including I put a video up a while back that was actually an event of magma movement underneath Yellowstone, or not Yellowstone, I'm sorry, Mount St. Helens. And of course, there is the yearly earthquake swarm in Yellowstone that gives us great opportunities to map under the ground. I'm still waiting for that data to be presented from USGS. But looking in the Carolinas, or South Carolina to be more specific, Columbia, or near Columbia, has had a lot of activity recently. It's a little bit out of the park of recent or steady. So I'm wondering if this is going to progress to something else, or if it's like a precursor, or if it's just a random event. There was an earthquake series that occurred in North Carolina a year or two ago that it led to a 5, I believe, a 5.1 or a 5.2, and then it sort of calmed down from there, and we haven't seen much. Here we go. These right here are the ones I was referring to, not New York, but well, off the coast, as it were. And these have been rather random for me as well, seeing these. So once again, another one of my concerns, is this a precursor, or is it just another random event that will lead to nothing? Because like for instance, about 3 years ago, there was a series of small quakes in the New Madrid area, and it didn't really lead to much. Uh, there was just some steady, motions of the Earth, and that was it. Nothing very large. I think the largest we saw was a 2.7 at that time. As you can see, we do still have some events. Activity is still ongoing there, as it will progressively due to its nature. But nothing that, oh, it was a 3.2. That's right, 3.2. But nothing that stands out to be significant. More of the, and this is actually a good thing. When you see these smaller quakes, uh, unless it's a precursor, so I mean, there's always a caveat. But unless while you see these smaller quakes, it usually means that the ground is releasing that pressure slowly, and this is a very good thing because it means that the less likelihood that that pressure is just building, building, building to have a large event instead. So if you have a fault line and this is a localized area, the Madrid line. If you have a fault line and it is not having any activity, I would be concerned due to the fact that if there's pressure coming and it's not releasing, then it's building up. I'm still waiting for the report that's was supposed to be a study done this fall in Mono Lakes, just north of Long Valley Caldera, which is a supervolcano in California. There is magma that is coming up into the lake, causing mound formations, and it's very fascinating to me. And I'm hoping to get more information on that here soon, so that we can see what exactly is causing it and what's the nature of the event. And but like I said, a university in ties with USGS is doing the research. Should have been doing it this fall, I believe, but I have not heard anything else from it at this point. Of course, we had the slew of earthquakes off the Oregon coast, and it's basically been a thing I've watched for a while due to the area also being a place known for a geothermal study. These do not look to be related to that, but it doesn't, stop my mind from wondering if the activity that had occurred in the ocean floor might have increased the time frame of these events to occur. Uh, but as I zoom out, you can see, and the Earth doesn't work in micro sections. It works as a very large whole. And you can see the formations of events that have occurred through all these events. One thing that strikes me, as very intriguing, is there's a misunderstanding due to a certain science relatable information that comes out. The event that occurs, say a 4.0 happened. No, actually, let's go bigger. Let's say a 7.0 occurred in one fault line of the side of, say, Japan. Say, because they've been having a lot of activity lately. They typically do, though, but it's been a little bit more in size. All right, so say a 7.0 happens in Japan. Oh, sorry, my clock. Apologies. So say an earthquake occurred in Japan. That was a 7.0. The energy of that doesn't transfer as a whole to the next fault line. That's not how things work. The energy dissipates as it travels. Energy or matter is neither created or destroyed. This energy is neither, increased on its own accord. It takes the motion in the initial event and anything that may trigger further events along the way that could help it along. However, a 7.0 in Japan does not mean there's going to be a 7.0 equivalent of events. That's just not how it works. You have to consider the absorption of energy between the soil of point A and point B and the direction of that event. So the event may be downward or it may be upward, which means a lot of the energy is not going to transfer along the plane, which means that we can sometimes see a 7.0 and not see it trigger in another event anywhere. It could be a very isolated event. These things happen. Indonesia is a good point of that. A lot of the Indonesia quakes is due to and Sandwich Islands, by the way, is due to an upward and downward thrust of the plates. So much of that energy is transferred up and down, and that's why tidal waves is a major concern for those locations when these events happen, because there's a greater chance of a tidal wave due to that nature of the type of earthquakes that occur. When you see, actually a really clear one here in Haiti. So, say for instance, the earthquake that occurred. Where's the plate divide? Okay, there's too far over. So the event that occurred here, or events that occurred here, this is a downward spiral of the plates going inward. So the event that occurred here, a lot of that energy was an upward thrust, and because it was pushing the crust up. And this is a lot how your mountains and whatnot are formed in a way, as well as compression and things of that nature, like I said, absorbing. But this right here, this is a greater likelihood of a tsunami due to this nature, where the up push and down push can cause waves to be formed very quickly and very large. So, pardon me, lost train of thought. So, anyways, yeah, the event did not transfer equivalently to other places due to that nature, due to the nature of the way the plates are designed here, much as the way of Sandwich Islands. As you can see, these events, and this actually makes it better. This is my better example here. This event shows, if you look closely at the series, the line of the events, you can see there's a ridge, and that is where the crust is being thrusted up, and the portion that's going downward is going down. So you're not going to see a equal amount of pressure suddenly appear somewhere else. So that's why predicting earthquakes is just nonsense in most cases. However, it can be helpful when you're looking at places that do not have that same type scenario. So if you look at, say, an event happens in, what's a really good place to show? Yeah, I guess I could do here. So say an event happens in California. Say it's a very large event, and just north of San Diego, which we see a lot of here. This event can transfer more equivalently to a more localized area. So say you see a 5.0 here, there is a possibility that you can see a 3 point something, or even maybe a 4 further down the line of where that fault line interacts. And these are our localized fault lines in the United States, which is also a reason why I watch the Salton Sea a lot, which I think looks a little bit shaped like a butternut squash. I've been out of it for the past month due to about a month-long migraine, and so getting back to it, and this is my first update of the seismic information. So it's not completely in-depth, but it does carry a little bit of what's going on, including an increase of activity in Alaska, which is interesting. But Alaska is always active. That's something that a lot of people don't realize until they see the bigger events. Alaska has a tremendous amount of volcanoes and a tremendous amount of seismic activity that's constantly occurring. The fortunate thing is the landmass it's quite big. So an event that happens in a certain area doesn't necessarily mean all of Alaska has endured that. as I said, this is not my typical type of update, but I wanted to put something out there. I'm back in the mix, enjoying the science. I think it's a beautiful thing, and doing what I enjoy, which is science. So, cheers and science on.